Hello everyone. In this part of the module 8, we're going to talk about hypothesis testing on proportion. And this is the last part of this module. And what we're going to do is to talk about performing hypothesis testing on population proportion as opposed to population mean, what we've been doing so far, using the three methods that are common: critical region, the p-value, and confidence interval. We'll also talk about how to compute type 2 error, or beta, if you remember, and how to choose an appropriate sample size, which is n. So we'll talk about all these issues that we talked about for other hypothesis testing, but this time on population proportion. So when we talk about population proportion, we essentially divide the population into two groups of success or failure. And the P, the population proportion, is the members that are successes. Well, you can define success or failure different ways depending on the application, but the important point here is that we are testing on population proportion instead of mu, which we have been doing. Mu was average or population mean. Now, some of the examples: proportion of registered voters that favor universal health care. That is proportion, right? The test is not about average number of registered voters. Well, that could be a different test on mu, but this one is about proportion of registered voters. And you can see in this case, the whole population is divided to two categories of success or failures. You either favor universal health care or you do not favor, success, failure. And or proportion of manufactured items that are defective. Again, these items that are either effective, defective, or not defective. So, and we're testing on proportion of them. So, the parameters that we have is the true population proportion. That is what we used to have as mu, not as p, and then hypothesized population proportion. And this hypothesis population proportion is what we had before as mu naught, when the test was about average. And then we have a two-sided test, we have one-sided tests, as you can see, same as before. You know, in the case of, let's say, proportion of defective items, you can test whether the proportion of defective items are 0.4, 40%, and not equal to 40%. And then you collect a sample and you conduct this test. In that case, 0.4 essentially is your P naught. So how do we conduct this test? Well, you would have to estimate using the sample proportion. So you set up your hypotheses, null hypothesis and alternative hypothesis. Then you would have to collect a sample and calculate the sample proportion. So that is sample proportion. And how do we calculate sample proportion? We divide the number of successes by the sample size. Well, if you're doing the test for defective items, you collect a sample of, let's say, 100 items. You count the number of defectives, that is x, and I'm going to call it number of quote-unquote successes, and n is the sample size. And we'll talk about how to choose the appropriate sample size. And we call this p hat. This is p hat. This is our point estimate for population proportion. The test statistic, as you can see here, is z-score. And that is based on normal approximation to binomial. And you can see here, because we have this success or failure, the distribution is binomial, but we approximate that using normal distribution. So therefore, the test stat is a z-score. And as you can see, the parameters are x, which is number of successes, minus n times p naught. N is the sample size, and P naught is the hypothesized proportion. And you calculate the test stat z-score, and you can use the critical region p-values that we had for the z-score that we talked about before in this test. So it's the same z-test that we had after you calculate the test score. And I suggest you review the hypothesis testing reference guide to get a summary look of all these different tests and what are the corresponding critical regions and p-values for them. So let's talk about probability of type 2 error beta and appropriate sample size when the test is a two-sided test. When we have a two-sided test, we can calculate the probability of type 2 error by calculating this probability. This a little too big, but it's not really that bad. As you can see, the parameters that we have here is the hypothesized proportion. You got to have an estimation of the true population proportion. And that's what we need to have to calculate beta, or probability of type 2 error. And we have alpha here. So everything else is basically the same parameters. Then you can also calculate the appropriate sample size. For that, you need to have a desired beta level in mind, and you got to also have an estimation for population proportion. And using those, you can calculate appropriate sample size that will satisfy your desired beta level. And that's the point. And then for a one-sided test of greater than, this is how you calculate. Again, is a function of same parameters. And for alternative hypothesis one-sided of type less than, this is how you calculate beta and n. Probability of type 2 error and sample size. You can also calculate confidence interval for two-sided test and one-sided test. For confidence interval, as you can see here, for a two-sided test, when the alternative hypothesis, as you can see here, is two-sided, you can calculate the upper confidence limit and lower confidence limit here, but you got to remember that this p hat is the sample proportion. Just to remind you, this is the sample proportion, and it's equal to x divided by n. Number of successes divided by sample size. And you know the sample size, and you calculate the lower limit, upper limit, and that's the confidence interval, two-sided confidence interval. This is the lower confidence interval when your test is one-sided of type more than. These are important to remember. So you basically calculate the lower confidence limit only. And as you can see, the difference here is same as other tests that we had before. Here is z of alpha, where in the two-sided test you have z of alpha over 2. Again, the p hat is the same population, same sample proportion. And for the upper confidence limit, as you can see here, it is applicable when you have a one-sided test of type less than, and you calculate that using a similar formula. So this is how you calculate confidence interval. We're going to apply all of this in an example in the next video.